Okay, I'm going to do this triangle next. Remember, I have Q as my 90 degrees, so I have to start with the 90 degree. 7QR, SQR. Wow, I'm not sure where 7 came from, sorry. Then we're going to do this one. Remember the 90 degrees right here again? SPQ. Okay, now we've got our nice numbers to figure out our altitude. So remember, to figure out the altitude or figure out QS, it is just the square root of 8 times 10, so it is just the square root of 80. Okay, let's try to do this one in radical form. So do we remember our perfect squares? Should I write them on the board? I'm going to write them right here on the board real quick. I know you said no, but I think it'll help some people. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay. So what's the biggest number I can try to see might go in evenly to 80? 64. It does not. So I'm going to try 49. It does not. I'm going to try 36. It does not. I'm going to try 25. It does not. I'm going to try 16. It does. So I'm going to have the square root of 16 times 5. And what's the square root of 16? 4 square root 5 would be the final answer for this problem if you were to put it in radical form. No, it's 16 times 5. Times. I know you can. Okay. Let's look at B. What do I do? Somebody want to help me out? I want to find the length of TU. What would help me? What length might I want to find first? UW. If I found UW, I would have 2 parts of a right triangle, and I could use Pythagorean theorem to find the other part. If I want to find UW, what formula or what numbers, what would I do with the numbers to be able to find it? I'd square root the product of 13, 7. So 13, that's supposed to be 13 times 7. The board is causing me a small amount of issue. So 13 times 7 is 91. The square root of 91 is approximately 9.54. So I'm going to use 9.54. Is this a case where it would be better for me to use radical form? What do you think, guys? Am I going to get a really good exact answer for T to U if I don't use radical form? You're not. So this is one of those times where it's better for us to use radical form. So this is the square root of 91. So I go over here. 91 divided by 81 doesn't work. 91 divided by 64 doesn't work. 91 divided by 49 doesn't work. 91 divided by 36 doesn't work. 91 divided by 25 is not going to work. 91 divided by 16 doesn't work. 91 divided by 9 doesn't work. 91 divided by 4 doesn't work. So this is a number that does not have a perfect square, so we can just use the square root of 91. So since this is the square root of 91, and this would be the right angle, we know TU is my C. So I'm going to go 13 squared plus the square root of 91 squared equals x, my unknown, or TU squared. 13 squared is 169 plus 91. 169 plus 91 gives me 260. Gives me 260. Gives me 260. second, please. Sorry about that. Equals, what did I say? 260 equals x squared, so I take the square root of both sides. Yes. So x is approximately 16.12. 169 plus 91 is 260. You take the square root of both sides, and you get x equals 16.12. Okay, let's skip C because I do want to get to some of example 3. Okay, let's look at example 3. All right, let's look at this first one. Okay. We've got to find out what x is. Okay. We know the length of the hypotenuse of the big triangle is 12. And we know the side is 6. So if I'm looking at the blue triangle that I'm outlining right now, I'm going to put the hypotenuse over the leg. Now if I'm looking at the smaller triangle on the inside, what is the hypotenuse for that smaller right triangle? What is the hypotenuse? Where's the 90 degrees? What's across from it? 6 over x. Do you see what we have? We've got 36 equals 12x. We divide both sides by 12. We get x equals 3. Done. Yeah, so let's try it. Okay, so let's look at the black triangle. What's the hypotenuse for the black triangle? What's the leg? Okay, now I'm going to draw the triangle that I'm going to look at the inside. What's the hypotenuse? $10. And what is the leg? So I get 100 equals 24x. I divide both sides by 24. So x equals 4.16 repeating. Okay, I know this was a lot. There was a lot of new concepts in here. There was a lot of new things. I did give you a decent amount of homework, but we are going to go over this in detail on Monday, and then we're going to do a calculator activity that should really explain this even more. So you need